you to get used to some common molecules that you have daily interactions with. Where do you find carbon dioxide? When you breathe. When you breathe, and where do we get the carbon dioxide from when we breathe?
The air.
The air. We take in oxygen and we turn it into carbon dioxide, and plants do us a favor because they'll take the carbon dioxide and turn it into oxygen. So don't cut down too many trees. NaCl salt, well, I hope you realize it's in all your foods. Ammonia, where do you find that?
Bleach.
It's in your bleaches, it's in your cleaners. That is absolutely right. So anytime that you are using a tub and tile cleaner, it's probably got some ammonia in it. It's a key ingredient. The next one, question. And again, a significant statement here. There are some molecules. Now, all of these, you'll notice, have two elements. They're called binary because binary means two. So two elements. But these down here, they also have two elements. There are 7 elements on the periodic table. Whoops. There are 7 elements on the periodic table found in nature that are only found as pairs. Meaning, there are 110 other elements that are found all by themselves. They can be found as one single atom. But those 7, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine, those 7 are found in nature as pairs. And they are the only 7 that are found that way. So in other words, you will never find a lone oxygen atom just floating around. You will never find a lone fluorine floating around. They always be in pairs. And they get a special name, and that special name are diatomics. There's ways to remember that. 2 different ways to remember that. Let's see what we can do. Maybe not. Maybe. There it is. Ways to remember this. If you look on this periodic table, or if you look at your own home version of it, you'll notice that most of those 7 elements are found grouped together on the right-hand side, and they seem to make some form of numerical reference over here. Oh, that's exactly right! It's like I just kind of emphasized that. They make a 7 because how many of the diatomic elements are there? 7. There are 7, and they seem to point as if over saying, please take me with you. The hydrogen somehow got separated, but these are the 7 that are grouped together to help you remember. A second way is that you can take it as an acronym and try to remember it as one solid phrase, pronouncing it as Brinkelhoff. They are significant. If you are somewhat more clever and you want to mix around the letters, you could go with Finkelbro, if you like that more, or you could do Hobnickelthor, or you could, you could come up with any number of them, but typically, chemists and chemistry teachers like to refer to them as Brinkelhoff. I don't know why that became the established acronym to remember all 7 of the diatomics that are found in nature, but that is the case. So if I ever try to give you a hint and say something about Brinkelhoff, you'll know what I'm trying to reference are the 7 naturally found elements that are found as pairs. Pairs. Let's see, what do we got? Anything else? Oh, wow. So, well, number 11 just didn't quite. All right. Draw pictures of hydrogen gas. Draw a picture of oxygen gas. Draw a picture of neon. So, what I'm expecting from you on quizzes coming up next week is that you would be able to represent your newfound knowledge of diatomics is that is 2 atoms. And we represent atoms as spheres. Now, difficult for you as a student with a pen to draw these so that they look three-dimensional. I had the aid of shading to help me with my task. But as long as you're putting circles and they're touching, I'll understand that you understand that they are found in nature as a pair. So hydrogen gas is found as a pair. Complementary to that one would be oxygen. Oxygen also found as a pair of atoms. If you want to label those and put little O's on each one of the circles, H's on each of the other two, that's fine. But then, please don't think that all atoms in nature are found as pairs. Remember, the majority of them are not, such as neon is one of the monatomic elements. It's only found in nature as a single atom. Neon is one of those monatomics. Hydrogen, oxygen are found as diatoms. All right, let's contrast now what we know are molecules. Molecules are any time you have two atoms stuck together. Well, a compound, they have to be different. So, take this note, all compounds are molecules. Not all molecules are compounds. So get that straight in your head. Molecules, you could stick two atoms together and it's classified correctly. But compounds, they have to be different. So this is not a compound. This is not a compound, and certainly neon is not a compound. But your water, your salt, your sugar, your carbon dioxide, those are all compounds because they are different atoms stuck together. So there's a slight differentiation that needs to be made between the two. Now this gets back to the original statement about molecules and how they're formed. You are going to form molecules by adding energy or removing energy. There has to be an exchange of energy in a chemical reaction for you to have the creation of a molecule or a compound. So this goes for either molecule or compound, that you can't make them just by good looks or happy thoughts. You have to actually exchange energy at some point. Almost done. Hang it together here for just a little bit longer, and then all of our terms will be finished up here. Oh, and we have some prized entertainment coming your way. Oh my gosh, I can't wait. How do the properties of water and hydrogen compare to one another? So, let's see some fabulous videos that will emphasize these points here. Don't do this at home. Not that you have hydrogen gas floating around, but this is what happens with hydrogen gas. It blows up. It is made of H2. He did that with a remote detonator. He wants to show you. Big nerd. But if we compare that to water, water, you all know what its properties are, right? It flows. Oh, you like her, huh?
Yeah.
Hannah Montana fan or the new version of her?
A new version.
Oh, okay.
Arkansas was a good video.
She's bad.
She's ugly. She's bad.
Look at that. That is water right there. Turning into people dancing. That is awesome, and that's a wonderful property of... Oh, look at that. Oh, dancing. Woo! And they're floating on water. That's amazing. Because why? Because they're made of water. Are you a fan of the TLC there, Aaron? Can you sing it along with this?
I don't know the words. Like.
Oh, don't go chasing waterfalls.
Yeah.
Stick to the lakes and the rivers that you're used to. I know you're going to have it your way or nothing, but I think you're moving too fast.
Are you talking about the lyrics?
No, that was just off the top of my head.
Oh, okay. Wow.
Should we watch the Miley Cyrus video?
Did everyone get the idea behind the difference of the two? I hope you did. What does a chemical formula show you? Okay, so if we're looking at those two, you should be able to now tell me that hydrogen is made up of hydrogen and nothing else. It's got two atoms of hydrogen. But water, in fact, is made up of two different elements. It's made up of hydrogen and oxygen. So it has two hydrogens and 1 oxygen. So you should be able to tell me, when I give you a chemical formula, what the elements are and how many there are. Just by looking at this formula. All that information comes out of it. Amazing. Your turn. You have to now classify on number 17 what we've got. I've got some very, very archaic, simple images there. This is kind of what I'm expecting you to be able to draw on a quiz. And you have to tell me, well, what are these things? Are they atoms, elements, molecules, compounds? So let's look at choice A. Choice A has 2 different elements. It has nitrogen and hydrogen. So, does that make it a molecule, a compound, an element, or an atom? It is a compound, you're absolutely right. But could it also be anything else?
A molecule.
You're absolutely right, it is a molecule as well. Very good. Looking over here at hydrogen, well, how many hydrogens are there?
2.
There's 2.
So it's an element.
It is an element, you're absolutely right. It's a diatomic element. What else can it be classified as?
Atom. Molecule. Compound.
A molecule. Compounds have to be different. So it's a molecule because it's 2 atoms. It's an element because this is the way hydrogen is found in nature, as a pair. This is helium. What is helium? It's an atom, and it's an element. You're absolutely right. It is not a molecule because molecules take 2 atoms together. Compounds take 2 different ones. So that should help you with letter D. What is it? It is a compound, and it is a... That is correct. Now it's your turn, number 18. You have to draw images of water, chlorine, and neon. Draw circles and make them pretty. When you are done, we are done with our stinking notes, and that's so cool. You could take a brief moment and jot down some ideas of what an element, atom, diatomic, molecule, and compound are, if you choose. I would be wise in doing so. I will help you through the process, though, because I'm your bubby, right? That's right. So if we're looking at water, water has 2 hydrogens and 1 oxygen. What about chlorine?
I don't know.
Why? It's a diatomic, so how many atoms should it have?
2.
That's right, it's the Brinkelhoff. It's the Cl in Brinkelhoff. Somewhere here. There it is. So it's got the 2 atoms. That's how you should represent your chlorine, with 2 little circles. And then, lastly, is the neon. How many circles should you draw for neon?
1.
Just 1. Why?
There's only 1.
It is only 1. What do we call those type of atoms that only have 1? Monatomic. Monoatomic. You're absolutely right. Very good. So, as we move forward in the notes, you'll notice the last task for you to do at some point before October is you have to complete the definitions, you have to do the book work. I will not assign it per se as homework. And